So far, we have so far we have learned about how AI reads words using tokens and embeddings. But how does it actually understand full sentences, paragraphs, and stories? How does it decide which part of the text are important and what can be ignored? The answer lies in a revolutionary invention called as the transformer, and specifically the first half, which is the encoder. So, in general, transformers are part of two important components, the encoder and the decoder. So, today we are just going to focus one on the encoder, and then in the next video, we'll talk about more on the decoder side of it. So, without wasting time, let's open the box and understand how the transformer encoder works. So, talking about the transformer, right? So let's try to understand the transformer first, and then we go on to an encoder side of it. Now, transformer is, when we talk about transformers, so transformers are nothing. It's just a machine learning model. It's just a machine learning model. The architecture is basically designed to process sequences like sentences, paragraphs, and even an entire book. And as we, already had gone through the transformer, it was first introduced by the researchers at Google in 2017, right? And in the very famous, paper titled as "Attention is All You Need." It basically changed the entire world of AI because it was the one which basically made the models smarter, right, faster, and better at understanding the long text. Almost all the modern models which you see today, which is a BERT, GPT, T5, Llama, and so many more, are all based on transformers. Now, in the transformers, as we mentioned, the transformer has two important part of it, which is called as the encoder, and then the other one is basically a decoder. So we'll focus more on the encoder as of now. Encoder. Now, encoder is just like a reader. It, its whole objective is to basically read the input sentences carefully and completely, and then create a smart understanding of it. So, whole idea is it basically summarizes the meaning of the entire input into something the computer can use to make predictions, classification, and translations, and so many more. Well, actually, if you find it hard to understand in a technical terms, I can try and explain in a non-technical uh, terms as well. Just imagine a school teacher reading an essay. Now, she doesn't memorize every single word. All she just do is understand the theme, the main points, and important details. Obviously, during our childhood, no one wanted to, memorize everything. All we just had to do is we just would take some pointers on a special, part of it, and that's it. So all the main points, the important details, and everything. Similarly, the encoder reads the sentences and builds a smart internal summary. So it does not memorize everything, it just builds the smart internal summary. So let's break down this encoder into smaller steps, right? And see how the encoder actually processes the sentences. So when we talk about, the steps for the, encoder, right, it basically works on, five-step process. So step one, and step one is basically the one which we already saw, which was about the tokenization and embeddings. So the input sentence is first broken into tokens. Each token is converted into a numerical embedding, which is a list of numbers. The second step is the positional encoding. So machines don't know the word order naturally. Now, in order to help the model understand the position of each word in the sentence, we add something called as the positional encoding. For example, again, we'll take the same example of India is beautiful, right? So the position, this one is basically a position of 1, right? And this is a position 2. Beautiful is, position 3, and so on and so forth. So positional encodings are added to the embeddings as well. Then we have something called as the step 3, which is about the attention mechanism. Again, we have already gone through the attention mechanism. So the encoder then applies the self-attention to it, which means every word looks at every other word and decide how important they are to each other. Now comes with a step 4, which is about the feed forward neural network. So after attention, every word's representation is passed through a small neural network to mix and refine the information. And that's what we do in the feed forward neural network as well. Now we talk about the final step, which is the step 5. So, which is the process is nothing, it's just a repeat process. So multiple encoder layers are stacked together, just like you are stacking a Lego blocks, and each layer refines the understanding more and more. So all these steps are part of each encoder layers, and each layer basically forms it. So transformers are a bunch of encoders being stacked together, and when the information flows through, it has to flow through the all of the encoder block as well. Now let's pause and understand this self-attention a bit more, which is part of the attention mechanisms. Let's try to understand this self-attention a little bit more, because this is the part which is the heart of the entire encoder, right? So self-attention, we have already discussed about attention in the previous video, but then again a bit more on a deep dive of it. So in a simple view, when we are basically, processing a word, the model looks at all other words and decides how much attention to play. For example, in a non-technical manner, right? Let's say we have a sentence called as the dog chased the cat. Now, when we are basically encoding the word chased, right? The model gives more attention to, dog and cat because they are the subjects of the action, and less attention to the, right. Now this basically helps the model understand the relationships better. We already had a discussion about it. So self-attention basically calculates three things for us, as we mentioned, which is a query, key, and the value, right? It then uses the mathematical operations like dot products, softmax to decide how much of each token influences every other token. So the question comes across that we saw in the previous steps that we had multiple layers altogether. So the question comes across, why do we need so many layers you know in the entire transformer engine, right? I mean, you know so many of the encoded layers are needed. One layer might have been enough in order to understand. So what actually happens is, so this when we talk about the layers, so each layer that you look into it, right, it basically captures more complex relationships. And that's why, like, the self attention was important for us to understand the, relationships. The first layer, basically, of the transformer on the encoder part, basically focus on the small details like the neighboring words. And the deeper layer basically captures for the big patterns like, full sentence meaning, the tone, the mood, and all. So, for example, in the previous example, which was the dog chased the cat. So I'll just write it down. Dog chased the cat, right? So what the first layer basically, is going to do is going to understand dog chased cat. This is going to be the, the first layer because obviously it's focusing on more on the dog and cat if you look into the chase perspective. In the latter, layers, it will understand the word like, understand like action, right? Emotions, right? Something like, who did what. So in general, the more layers, the deeper the understanding. And this is a very specific, concept about the transformers. The more layer, the deeper the understanding. So that's all with the, encoder agenda. So let's quickly just go ahead and, summarize whatever we have seen so far, right? So we saw like, how the encoder basically works. So we had a input sentence, right? First we, will basically tokenize and embed them. Then we add some positional, encoding into it and put it onto the embedding as well. The third part is the self-attention part, focusing more on the relationships, right? The fourth part is the feed forward neural network, which basically process the information. Then we have a, stacked of the multiple layers, which is like a repeat part, right? Stack the multiple layers. The whole objective of having a stacking of the multiple layers is to build deeper understanding. And then we finally get an output on top of it, which is a rich, smart, representation of the input. Now this output can now be used for task lives, whether you want to do a translation, whether you want to summarize, whether what you want to classify, or any other thing which is in your mind. Now encoders are heavily used in models like BERT, for understanding the text, in T5 for text-to-text transfer transformer, sentence embedding for matching questions, and even the search engines that you see. So whenever you need deep understanding of input, encoders are basically the superpower for you. So friends, the transformer encoder is like the brain that reads your message, thinks deeply about it, and prepares it for the action. Without this powerful reader, AI would still be guessing randomly. Now that you understand the magic of encoder, in the next lesson, we'll explore the decoder, all part that actually generates answers, writes poem, chat with you as well. So see you in the next video, and let's keep building our AI superpowers. Thank you.